In this lesson, we're looking at the periodic table. And it's an important topic because it links into your groups, and it's specifically group 1, 7, and 0. It has links with your atomic structure, bonding, the reactivity of those groups, and lastly, the history and the development of the periodic table. Now, here's some general rules about the structure and things to know. We've got numbers going across the top of the periodic table. We call these our groups, and you can see there's a total of 8 ranging from 1 to 0. And of course we've got that center section which is called the transition metals. Along with this we have numbers going down across it. These are called our periods, and again ranging from 1 to 7, highlighting those periods going across the periodic table. The periodic table splits up metals and non-metals, with our metals being found on the left-hand side, making up the majority of the periodic table, and our non-metals being the minority on the right-hand side. And we can see there that staircase that divides and separates the metals and the non-metals. A general idea with our periodic table is how it's arranged, and we can see here there's an increasing of the atomic number from left to right, and this goes all the way across your periodic table. And lastly, there are links between the structure of an atom and its placement on the periodic table. Let's have a look at that. We'll take lithium here as our first example, and we can see that lithium is found in period 2. This tells us that it's got 2 electron shells. It's also in group 1, and the group number tells us how many outer shell electrons it has, in this case 1. Let's have a look at one more example. Aluminium. It's in period 3, which means it's got 3 electron shells, and also in group 3, which indicates it's 3 outer shell electrons. And we can use the placement of atoms on the periodic table to help us draw the electronic structures that they have. Right, let's apply this to some past paper questions. Here's your first one. Take the next minute to work through this. If you finish early, skip ahead. Otherwise, pause for more time. Let's see how we've done. Here's the answers. And we can see here from their placement, they're both in the same row, which would indicate that they have the same period, and therefore the same number of electron shells. And then we can also see that they're in different groups, with sodium being group 1, which means 1 outer electron, and chlorine in group 7, indicating 7 outer electrons. But the general idea here is that they're in different groups, therefore different outer shell electrons. Here's our next question. For this one, take the next 2 minutes to work through this, and of course, if you finish early, skip ahead. Otherwise, pause for more time. Let's see how we've done. Here are the answers. Now we can see that element B is found in that center section, which is our transition metals. D is in the second column, which is group 2. C is found on the final group there, which is known as group 0, sometimes referred to as group 8. And the element with the atomic number of 4 would be the fourth element on the periodic table. Let's summarize what we've learned. Groups, our columns, also tell us the number of outer shell electrons. The periods going across tell us how many electron shells an element has. The periodic table increases by atomic number, which is indicated by the small number of each element. And lastly, the division between metals and our non-metals. Now, I hope you found this lesson useful. Our next one will be on the development of the periodic table. Now, please don't forget to like, comment, and subscribe, and I'll see you in the next one.